what's next in terms of the volume and area work we're doing? Yesterday we looked at the surface area of prisms and the specific case of cylinders. Today we're going to look at one of the other solids we looked at, actually two of the other solids we looked at. We're going to look at cones, and then later on I think coming up is spheres. Well, the surface area of a cone is made up of the base, if it's a solid cone, which will be a circle, the circular base, and the sides of the cone. Well, if the base is flat, the sides are curved, that's called the curved surface, and that's given by this formula, pi RL, okay? Where R is the radius of the cone, and L is this measurement, the slant height, okay? The slanted height here, Miss Martin's called it the slant height, not to be confused with the height. Now, on a lot of the cones we'll work with, that will happen to be a right angle here, and those three measurements are going to be connected by Pythagoras, but that's not necessarily the case. And anyway, actually, it is the case, yeah. We can't, this only relates to what are called right circular cones, okay? These ones here. How do we use it? Like any formula, we just apply it. Find the surface area of the following cone. So we've got the height, we've got the radius. The surface area will depend on two things. Pi r squared, which we can work out because we have the 3. Pi rl, which we can't do at the moment because we don't have L. What did I just say? That's a right angle triangle. Pythagoras' theorem. Work through that to get that the slant height is 5. Pi times 3 times 5, 15 pi. Pi times 3 squared, 9 pi, 24 pi. That's an exact answer. Type that into a calculator and you'd have an answer to how many significant figures you want. Now, I know some of you are screaming at the screen, but we see where that comes from. How on earth have we jumped to that? Well, can we prove the curved surface area is pi RL? Yes, we can, but you don't have to prove it. So, this working on this page, I'm going to put as a YouTube video you can work through, okay? But can you see that we do end up with that result? You don't have to prove it, that's there as a bonus. Let's get on today with the work that Miss Martin wants you to do. She wants you to do from 9H those questions, which should have these answers. And at the end of today's lesson, that's going to be part of what I want you to upload as well as yesterday's work, but it's not all that we want you to do. The second shape we want to look at is the sphere. We've already talked about the fact that the volume is 4/3 pi r cubed, a formula you'll be given on the exam. If you need to use it, it's quoted in the question. Similarly, the surface area of the sphere is 4 pi r squared. I don't think you need to learn it. I'll check that when you're back. Notice how similar they are. The volume, 4/3 pi r cubed, a volume having r cubed in it. What are the units of volume? Centimeters cube. The area, r squared in it. Okay, so how do we use that? Find the surface area of the following sphere. If you're given the radius, you do 4 times pi times r squared, 4 times pi times 5 squared, 5 squared is 25, times 4, 100, 100 pi. That would be an exact answer in a question that says it wants it to 2 or 3 significant figures. 3 sig fig would be 314 meters squared, 3.14, which is pi multiplied by 100. And then you'd correct it depending on the accuracy you want. Okay, so again, like everything else we've done, read the question, check on the formula you need to use. Hemispheres. Hemi, half. So the volume of this hemisphere, volume, I think she means, let's put a line through that, shall we? area of that, and I can't write very neatly with the just the little touchpad, so we're just going to look at A. The area is going to be the combination of the same as for the cone. It's going to be the base. If it's a hemisphere, if it's a solid hemisphere, you'll have a circular base. Yeah, solid hemisphere has a circular base. And then it has all the rest of it, the curved surface, will be half of the sphere's area. Okay, that's all we're doing. We know that the area of a sphere is 4 pi r squared, which you can write down. You don't need to learn it, just write that down in your notebooks. And we know that a circle is pi r squared. Work both those out, add them together, 12 pi, or on a calculator paper, 12 times pi, and get an answer. Okay then, you try these ones. Now I think we did 9i before when we were working out the volume of the sphere. Now we're working out surface area. So the only other thing to do is just read the question. Is it area you want or is it volume you want? One or the other, okay? Area or volume. These should be area questions. Here are the answers. Good luck with those. Could you upload Wednesday and Thursday's work together? Doesn't matter if you put it on the Edmodo, if I remember to make an assignment, or you send it to my email. Good luck with those and have